Pace, are you there? Okay. Okay, dear participant, and welcome back in this ongoing training program. Today is the 20th lecture of this industrial training program. Okay, and today the topic which we are going to cover is matrix algebra, and this topic is highly useful for data analytics, data science, machine learning, model, and many more. Okay, so all type of the operations which we will discuss in the today's session will help you in data analytics, data science to develop any machine learning model. Okay, so matrix algebra is the most important topic in data science. I have shared my screen and you can see this is my desktop. Okay, yes, I am taking new file from this side. All of you know familiar how we can take. Yes, so this is our new file and the version. Yes. So the topic which we are going to discuss today, matrix operations and linear algebra. Matrix operations and linear algebra. This is the topic which we are going to cover today. Okay, and to mark it down for text. So we are starting with how to create matrix. This is the example one. Example one. Create a matrix. So for that, we are required to import numpy. Import numpy is np. Array. Okay. So we import numpy as np. Control and enter. Yes. After that, we will start to how many rows we need to require. So rows we are using the input functions. Okay. Int. Then use here input function. Enter the number of rows. Enter the number of rows. Okay. Column. And then after we are required to use column. Here we are using calls and here we have columns. Then print enter matrix element. matrix elements, and then we have matrix is equal to, we have the matrix is equal to np dot array. Okay, then we have to back with all the inputs which we have assigned at this place. So for that we will start from input. We will start from integer. Then after we have first we have for I j in range columns. Okay, calls, we give the calls at a place. Then after we have for I in range range of rows. Okay, then after we have print matrix. So here we are using input functions, and according to our input we can create the matrix. Okay, so control and enter. First we are required to enter here rows. So if I am entering here number of rows are 3, then number of columns I am entering here 2. Okay, now okay, matrix element, there is some error, rows. Okay, here, okay, here is row, I put here row only, so that's why here is also only row. Again control and enter. So 3 rows, 2 column. Now uh, 3 by 2, we have 6 elements are required, so we can take any 6 element: 12, 13, 14, 21, 23, and 25. So these are, we have 6 element. Control and enter. Okay, here is also we have mistake. Okay, it's saying invalid lateral int with base 10, 12 of this 3 and 3 we have is 6. Okay, so here is some mistake. Okay, 2 and 2, the mistake, this is okay. Then we have the int function is also okay. Int, then input, it's fine. For j in the range calls, then we have for I in the range row. Okay, np total array operation is fine. Np total array j and I, rows and rows, np matrix, no issue. There is also no issue. 2, 2, 1, 2, 3, 4, only 4. Okay, 1, 2, sorry, Okay, if I'm using 2 and 2, 2, comma 3, comma 4, comma 5. No, into. This is correct. This is also
So you
correct.
have to enter the values one by one, no? We are not using split here. We have to enter the values one by one.
Two, three, for history search. Okay. Two. Yes, yes. Thank you. So we have to enter the value one by one. Thank you, ma'am. Actually, sometimes confuse the letter to as we are using arrays. For that, we are entering the all values all together. So yes. So we have to enter all the values one by one. This way we can check the matrix by using the
അടുത്ത ക്ലാസ്സിൽ
dear participants, some of the participant mic is unmuted. Okay. So after that, if you want to check we have some shape function. Okay. Suppose that I have this is the second example. A matrix shape. So here suppose that I have A is equal to any matrix I am taking here, NP is equal to sorry A is equal to NP dot array. We can directly write the matrix without using input function. Okay. So here we have is first row I have the element 1 comma 2 comma 3. Okay, and in the second row I have the element 4 comma 5 comma 6. So these are six elements are there. If you want to print this matrix we can use here print A. So this is the matrix 2 by 3 order. Okay, if we want to check here the shape function by using the shape function. Some of the example maybe we have discussed in the previous session, but not all. Some of the new operations are there. So previous operations which we have used already, we are revising here. Shape, okay, is equal to then we have to use here a dot shape. Okay, so this will return the shape of the matrix. If I will execute this statement, you can see the shape of the matrix is 2 by 3. And the same operation will be the same statement and the function can be used when we have the large data set. Okay, large data set means we have the number of rows are more than 50,000, 1 lakh. Okay, but we are not have the numbering or anything because when we import the file in Jupyter Notebook, we have only the file name, and from that we have to assess, we have to read everything for the understanding of the data set. So this type of the operation will help you to check the size of the data set. Okay, so this is the shape function. Then we have print function. Okay, here we can assess the number of rows. Okay, any row if you need. Just like you can see here, I have rows. Okay, then is equal. Here we are using a dot shape function, and here I am using 0. Okay, 0 we are using for rows and 1 we are using for columns. So if I execute this statement, you can see this is the counting of only the number of rows. Okay, you can see the number of rows here are only two. So sometimes if you have the large data set and you want to count the number of how many entries are there in your data set, so you can simply use this statement. Okay, data frame. When we create the data frame, after that we can uh, apply various type of the operations. Okay, so the all the information which you have any file just like a CSV or Excel file after importing, we have created the data frame and store inside the df. So in the place of a, we will use df. So if you want to check the number of rows, then df dot shape 0, and one we are using for the column. See, if I am using, I copy and paste here columns. Okay, COL number of calls, and here I use 1. So 1 is used for the number of the columns and 0 is using for number of rows. Okay, with the shape function. If you are using the shape function, then you can access the number of rows as well as number of the columns. So here you can see the rows are 2 and the columns are 3. In this way we can apply these operations. Okay, so addition and subtraction we have already discussed, so we can skip this function. And if you need the scalar multiplication, okay, so addition and subtraction are the simple, but if you need, okay, we discussed a is equal to, I have np dot array. So here we are using the size of the matrix. We can take simple, just like 2 comma 3, and in the second row we can have 4 comma 5. Okay, this is the a matrix, and then this is the b matrix. I'm using here b, and this is 3, then 5, it is 1 and 2. Okay, these are two matrices. So here you can simply apply various type of operations, just like for addition, you can use here print a plus b. So this will return the addition of two matrices. For subtraction, you can use a minus b. Okay. For multiplication, you can use print a product a. So this multiplication which we do here for two matrices, this is the element wise multiplication. You can see this is a matrix and first element is 2, and here is also first element is 3. So 2 by 3 we have is 6. Similarly 3 and 5, 3 into 5 we have is 15. Similarly 4 into 1, 4, and 5 by 2 we have is 10. So this operation which we apply here for the multiplication is the element wise multiplication. Element wise multiplication. So how we can do the actual multiplication of the two matrices? Anyone please? How we can do actual multiplication of the two matrices? We have to use here a at the rate b. So this is the multiplication of matrix A with B. Here is the element wise multiplication. Okay, but here multiplication of A matrix with B. Control and enter. This is the value. And the other operation we have one more by using dot function. That also you can use for the multiplication of two matrices, just like a np dot. And here we have A comma B. Control and enter. You can see the values of these two operations we have same. See last one. Okay. So either you can use a at the rate b, or you can use np dot function a comma b. So both will be can be applied for the multiplication of two matrices. And for the transpose matrix, what you can do for the transpose matrix? That is again simple. We have already used it. What will be the operation? Dot t in uppercase. So this will return the transpose of the given matrix. So this is the A matrix. You can see here if you will print A. So you can see this is the A matrix, actual A matrix, and this is the its transpose matrix. So when you will use A dot T, this will transpose the given matrix. Very simple operation. What is the operation to get the identity matrix? Anyone please? NP I is equal to what is the operation? A function name to write identity function I. Okay, print I. Or either you can use in this way. This will also print the value. Okay, so in Python, if you store the value in I, if you want to print, you can use the variable again in the next line. Okay, so this automatically print the matrix. Or either you can use also the print function. Print I. Both have same meaning. This also can be used. Okay, so zero matrix, ones matrix. Okay, how you can create the zero matrix? np dot zeros. Okay, np dot zeros, and then you can assign the any order. I use here 2 by 3, and then for print I am using z 0, np dot zeros. Okay, here I have to put the order. I have to put the order. Now it is fine. This is the order. Okay, so this bracket we use for the function, this one, and this the for order, which order we need the matrix. Then if you want to write the ones matrix, the similarly you can write the ones function, just like I am copying and taking the new shell. Here I am using ones. So in the case of ones, all the element will be one. I use here the variable is o and o, control and enter. So all the element you can see are one. Now the next and important part is the slicing. Slice of the matrix. Okay. So okay. First we are getting here any matrix. The operations we have are slice and slice first row. Okay, how we can do? First, we have to create any matrix. We can use like A is equal to NP dot arrange by using the arrange function. Okay, we can create the matrix. We are taking the element from 1 to, suppose I am taking 26. Then you can use the reshape function. Reshape. Okay, So how many elements are there? 1 to 26. These are 25. So the matrix will be 5 by 5 order. Okay. Then if you want to print this matrix, we can check it whether it is correct or not. Control and enter. Yes, it is fine. You can see we have the matrix having the element 25. But here we take the range from 1 to 26. So according to this one, we must have 26 element. Can you please explain this one? So when you will apply this range, so always we have one element less at the place. Okay, this is n plus 1. This is n plus 1 if n is the number of the value. Okay, so this value will be always less than 1 when we will use here. When it will return. So the meaning of this one is 1 to 25. Okay, so this is the matrix, and now we want to slice the first row only. So see here, we will write here various operations by using this example. Print a matrix. Okay, and see here very carefully. I am perfect audible. Voice is clear. Okay, so here I am using colon 2. Okay, then comma colon. Okay, if I will execute this statement, so this is extracting the first two rows. See, this is the first two rows. Okay, uh, this is the first row, and this is the second row. So first you are required to understand this one. The meaning of the value which we will enter after the colon, this will be the this will be after the comma, this will be used for columns, and before we are using here for the number of the rows. Okay, so here the rows are starting from number 1. If I am using here 1, then control and enter, only one row is there. If I am using here 2, then first two rows are there. Okay, if I am using here 3, then first three rows are there. Okay, but all the column, the meaning of this one is all the column. If I do like in this way, and here I have the value 3, control and enter. See, okay. So if you are using all the rows, the meaning of this one is all the rows. But when you will use here, okay, this will assess the columns from last. Okay. So when you are entering here 3, so the last column are there. When you are entering here 1, sorry 2, control and enter. Uh, we have this one. So first what I have to do, if I comment this one. Now see, so all the column, but three rows are there. If I'm using here one, then all, starting from first. Okay, if I'm using here one, then it is starting from first column, second column, second onward. Okay, see very carefully. If I'm using here one, then the index of second column is 1. Index for first column is 0. And for this we have is 1. So from this place onwards, all the rows, all the column are there. If I am using here 3, control and enter, now this will start from index 4. First row, first column, second column, third column, and fourth column. 3 means 3 means fourth column. So this will start from fourth and fifth. So these two columns are there. Dear participant, there is mic is unmuted from one participant. Just 1 minute. I okay. Now, if you have any question, you can put the question in the chat box only. So once again, see here this operation. If I am using here 1, okay, or if I am using here 0, I can use here 0 also, control and enter. So you can see all the columns are there. Okay, it starts from 0th index column. Okay, the index of first column is 0. If I am using here 2, then it will start from third column. 2 means 0, 1 and 2. So the index of a third column is 2. As you know, the index in the Python starting from 0. That's why. Okay, so now when I will apply this operation, you can see third, fourth and fifth column are there. And again, if I am using here 4, okay, control and enter, only last column is there. So there are 5 columns. You got the idea how we are using. So you are required to manipulate all these operations. Sometimes you are required to take the sub matrix. Okay, sub matrix, suppose that I am taking here uh, I am taking here 1 colon 4, and here I am using 2 colon 5. Okay, control and enter. So this is the submatrix. This is the submatrix. So what you can see here, one means these are the rows. So 1 means second row. So from this row, you can see 8 is there. 8 is there. Okay. So this is the row 2 and column third. This element you can see. Okay. So the rows are take. So 1, 2, 4 means 3 rows will be there. One less from this side. So 1, 2, and 3. So these 3 elements are there, 8, 13, 18. You are required to compare all these values, how we are assessing. Okay. And for this, you can see 3 and 4, one less. Okay. Starting from 2. Okay. 2 means third. 2 means third row. Sorry, third column. Okay. So this is the third column. So this is the third, then 4, sorry, index is 2. Okay. So index 2, index 3, and index 4. in this way. So these elements you can see here at the place. So this is the sub matrix. You can manipulate all these values, and according to that, you will have the sub matrix. If you will start from zero, if you are starting from zero, okay, and here also you are starting from 0 to, I am taking 3, control and enter. You can see the sub matrix. Okay, 0 to 4 means 0, 1, 2, 3, 16 up to 16, 1, 6, 11, 16. You can see. And 0 to 3 means 0, 1, and 2. Okay, one less from right side, one less from right side. So keep these things in mind while applying this operation. But as soon as you will try to use and manipulate these values, check and verify, you will understand. Simple operations are there. So in this way, we can assess the sub matrix. Sometimes if you are required to replace any element from the matrix, we can do. So here I can take in the next row. If you want to replace any element, uh, we can replace one element and we can replace many elements. Just like see, I'm using here A and colon, one, one colon 3, then comma, I can use here 2 colon 4 is equal to 100. I'm using here 100. So this element will be replaced by 100. See, can we check it? Print A. Print A. See, this value and this value. 1 to 3, 2 to 4. If you are doing here, just like I'm taking 4, and here is also 1 to 4, control and enter. So you can see these elements are replaced by 100. Okay, so you can see here these element. So all these elements are replaced by 100. So in this way, if you are required to replace the element in the matrix, you can give the range, and according to that, this will replace the element. Okay, you can update the matrix or replace the sub matrix. Go to the idea how we are using this operation. You can put your question in the chat box. Okay, because I have restricted unmute the mic. Is it clear? If you have question, you can put in the chat box. Okay. So in this way, you can apply this operation and to get the determinant of any matrix. Can you please let me know, anyone, how we can get the determinant of any matrix by using NumPy? I think we are using first time. Okay, suppose that I have very simple example. I am using here for determinant. Okay, so suppose that I have A is equal to NP dot array, and here inside I have very small matrix I am taking. In the first row I have the element 2 comma 3 comma 4. Okay, and in the second row I am taking the element 3 comma 1 comma 5. These are the element in this matrix. And if you want to compute determinant, then we will use as np dot linear algebra. This is linear algebra. Okay, this is the function linear algebra, which we can use for determinant, for inverse matrix. Okay, so from linear algebra we are taking determinant of a matrix. Okay, see the sequence. NP is the library, NumPy. Linear algebra is the part of NP involving the all type of the linear algebra operations. And from that module, we are taking determinant function. Okay, so when I will execute, you can see uh, NP linear algebra. Okay, for determinant, we should have the number of rows. We must have square matrix. Okay, one row is also required. I am taking 3 comma 5 comma 6. Okay, so when you have this type of the error, you must read this carefully. Okay, so mostly your prom will be mentioned in the last row of this error message. So last two dimensions of the array must be square. Okay, so from that you will have the idea what type of the prom we have. Okay, or any kind of the error, so you can easily assess the error. Control and enter. Now you can see we don't have any error message now, and our function executed properly. So this is the way to compute determinant of any matrix. If you want to get inverse matrix, okay, that is also very quite easy. For the inverse matrix, you will do here uh, inverse. So here we will use only inverse function. Okay, we have inverse function. So this automatically calculate the inverse matrix of given A. So this is the inverse matrix. Okay, if you want to verify, if you want to verify for that, how you can do? Yes, verify. You can print np dot. We have the matrix of two matrices. Okay, so we have to store the value. We have to store the value of this operation. Okay, inv is equal to, then we can use it. And here inv. Okay, so np, then dot. First we have is the A matrix, then its inverse matrix. Okay, so when I will we will multiply these two matrices. Oh, I have to execute this first, then I can do this one. I apply, then we have this one, and then this one. So you can see the diagonal element here is 1. These are very small values, but approximately these are 0. Okay, these are 0. If you take small matrices, then this will be easy to verify. We are taking this element. Okay, and Okay, this is the A matrix. What is the problem? One bracket is missing. Yes, okay. So this is the determinant of A, and then this will give the inverse matrix of A. Then yes, you can see. Okay, this is one, and this is one. Okay, this is approximately zero value. Okay, this is also zero. So this is the identity matrix. So in this way we can use. We can verify the matrix by taking the dot product of A matrix and its inverse matrix. Okay, and then after we have very interesting functions, eigenvalues and eigenvectors. Eigenvalues and eigenvectors. If we, uh, these are also highly useful in machine learning models. Okay, eigenvalues and eigenvectors. If we are required to compute, how we can do eigenvalues and eigenvector. I am not presenting the theoretical part. We are using only the computing. Okay, eigenvalues and eigenvector. So this is also very quite simple here. We are taking one example. Suppose this one, the matrix of A is equal to this one. If we want to compute eigenvalues and eigenvector for this matrix, we have a 2 by 2 order matrix. Okay, so values, these are the eigenvalues, and these are the vectors. Okay, will be equal to, we have np dot linear algebra. Okay, this is the linear algebra function. Then you will use here, the function is eigen, eig. Okay, this function is there. Then pass the value a. So from a matrix, this function which we apply at its place will calculate eigenvalues as well as eigenvectors. Both will be computed by using this single statement, and will store here uh, this in this variable we have the values, eigenvalues, and at this place we have eigenvectors. Now if you want to print the eigenvalues, print only the eigenvalues. So eigenvalues will be eigenvalues space, here you will pass values. Okay, and then print eigenvectors. Okay, here is vectors, this one. Okay, control and enter. Wonderful. Values, eigen array. NumPy has no attribute to lin. Okay, here is linear algebra. Okay, uh, L is missing. Control and enter. Okay, so these are the eigenvalues. These are the eigenvalues, and these are the eigenvectors, you can see. So we can compute eigenvalues and eigenvector in this way. Okay, then if you need to find out the matrix rank, okay, we can also calculate the matrix rank by using function. Very simple. I am taking the same matrix A, and if I want to calculate the matrix rank, okay, so print we have the function np dot I have linear algebra. I am copying this function np dot linear algebra. Okay, then we have the matrix underscore rank. So this will compute the rank of the matrix, then pass A. Okay, so if you are required to compute the rank of the matrix, then you can perform in this way. Again, we have very nice. If we, do you have any question related to these examples which we have covered right now? Please feel free to ask. I permit you to unmute your mic, or you can put in the chat box. Yes, please. Any question? Now you can unmute your mic. Any question, please? Okay, no question. So after that, sometimes if we have the system of linear equations and we want to solve, okay, suppose that how we can use, how we can do. Solve the system of linear equations. Okay, example, we are taking the example. Suppose that we are taking first equation we have is 2x plus y is equal to 8, and second equation I have is x plus 3y is equal to 13. So I have these two equations. Very simple example I have taken. You can have two variable, three variable, five equation. So according to that, the variables will also increase. See here, first we are required to write, we have to convert these two equations in matrix form. How we can do? The A matrix will contain np dot array, and here inside the coefficient of x and y in first equation 2 and 1, 2 comma 1. Okay, then we have the second equation, the coefficient of x and y from the second equation. You will choose 1 comma 3. Okay, so this is the matrix A. Then we have the matrix B, np dot array. Sorry, B is equal to np dot array. Okay, the values which are 8 and 13. The values 8 and 13. Okay, 8 comma 13. So we have now a matrix A and matrix B. So what you will do, we have the linear algebra. In numpy, apply the operation. So x is equal to, we have np dot linear algebra. Okay, so here we have to use the function is solve, then matrix A comma matrix B, then print X. Okay, control and enter. So these are the value. This is the value of X and this is the value of Y. You can use here X in uppercase. Okay, so very simple. We create this system of equation to the matrix form. There will be two matrix. One is A, which will be the coefficient of the variable x, y, and the second we have the matrix B. These are 8 and 13. Okay, you will store here. Then after you will use x is equal to np dot linear algebra dot solve. Okay, so this is the solver which will solve the system of equations by using matrix. Okay, a comma b, and then you will print the value. So the values will store inside x. So when you will print x, the values will return. So whether you have the 3 variable, 4 variable, 5 variable, the stuff will remain same. Okay, you have to get the matrix A, then B, and then X, and print the X. So this will automatically return all the values. Okay, you got the idea how you can solve the system of the equation, linear equation? Okay. Any question? See here, we have very interesting example. We have the student marks. We have students marks data set. Suppose that we have some data set, and marks are equal to, we have np dot array. Okay, here inside in this one. So we are using, then enter. So in the first row we have the elements. Suppose that these are 80, then 75 comma 90, then here comma and enter. In the next row we have 65 comma 72 comma 70, then comma and enter. So see the magic what we are doing here. 90 comma 88 comma 95. Okay, then comma and enter. Here is one more row and having the element 78 comma then 80 comma 85. These are the element. Okay, in the marks. So if you will print marks, we can use, yes, in this way. Marks, then pass the, no. We have to use slash n, then marks, control and enter. Yes. Okay, so if you want to get the average, okay, print average. colon space, and here we are using the function np dot mean function is there. Okay, mean function is there, and simply you will use here marks. Okay, comma axis is equal to 1. C, control and enter. So 0 is we are using for rows, 1 we are using for column. So these are the sum, and this is the average by vertical. And if you will take here 0, then control and enter. This is the average in this way. Average of first row, average of second row, average of third row, and so on. 1, 2, 3. If we are taking 1, control and enter. 1, 2, 3, 4. Yes, there are 4 rows. Okay, so when you are using here x is equal to 1, then we have the average of this row, then this one, and this one. We have 4 values, you can see. And if we are taking here 0, then we have 1, 2, 3. 3 columns are there. So this is the main column wise, and when you are taking 1, then it is the main row wise. Okay, so in this way we can apply this operation. So all these operations you can use for Irish data. Okay, you will apply all these operations for Irish data. So what is Irish data? Irish data is provided by the lab sklearn. Okay, so this data is free available, we can use for our operations. So what you will do, you will write here import numpy is np, and then from sklearn dot dataset. Okay, sklearn dot datasets import load underscore irish. Okay, irish is some dataset. So this is the libraries for sklearn is the part of scikit-learn, which are used for machine learning. Okay, so this is the one of the module which contain data set, and from this data set we are importing the data irish. We load the data irish. Okay, so if you want to read, then what we will do, we will store the data in irish variable. Okay, and use here load underscore irish. So by using this one, data set will be loaded, and x is the variable. Okay, is equal to iris dot data, control and enter. Yes, the data has been downloaded. Now the all the data which we download here is inside X. So only we will use X at this place. If you want to print X, control and enter. So this is the data set you can see here. Okay, this is the data set inside X, and there are one, two, three, four. Four columns are there. Now here you will apply the operations. You can apply here several operations. So just like I will give you some example, rest you will apply. Okay. If you have the data set, then how you can apply these operations. So first we are required to check the shape. We just now read the function shape. Okay. So shape, then a colon, comma, x dot shape. Okay, we will use this one. So this will return the shape of the data set. There are 150 rows and 4 columns. Okay, if you want to access the first 5 row, okay, if you want to access the first 5 rows, for that you will use print first 5 rows, colon, then comma. Here you will apply the operation. So here you have to use n, because there will be rows are there. That's why. So what you will do, you will use here x, then colon 5. See, control and enter. Yes, these are the first rows. First 5 rows are there. If you are using here 10, control and enter. Okay, you can see. If you want to assess first 3 features, if you want to assess first 3 features, okay, see, we can have some more operation. Print, okay, first 3 feature, colon. How we can do, here you have to use slash n, then we have x. Okay, from x we are taking all the rows and column 3, control and enter. So these are first 3. These are first 3, first, second and third. Okay, and if you are using a 2, so these are first 2. Okay, so in this way we can use these operations. There is also the correlation. Okay, there is a covariance matrix, we have the correlation, we can have the mean, we can have the transpose. So all these you can use these operations. Just like if you want to calculate covariance matrix. So here we have the example how we can use the covariance. So print covariance matrix, right? Covariance matrix slash n. Then we have the function np dot, this is the covariance function in numpy. Okay, so here you will use x dot t. x dot t. Okay, this is the operation. By using, you can get the covariance matrix. NP dot covariance x dot t. Okay, so this is the transpose of this x, and then outside we have the covariance function. So by using, we have the covariance matrix, as you can see at the place. Similarly, you can use the correlation coefficient matrix. So you can create, only the function will change. So this is all about the today's session and the important functions which are available in NumPy, and the operations are specifically based on the matrix and linear algebra. So all the operations which we discussed here in the today's session will be highly useful in the coming sessions when you will develop some machine learning model, and various type of study is required. Statistical method also we can use. So this is the simple example how you can apply the operations whenever you have the any data set. Also, this data set which we use here, Irish data. This Irish data is cloud-based data. You can use by importing from sklearn. Okay, but if you have the real data set in your CSV file or in the Excel file, okay, that also we can apply various type of operations which we have at this place. Okay, so all the operations are very useful. Functions are simple, but when we have the multiple functions and everything, we have to keep in mind very carefully, we have to use them. But if the syntax and the meaning are clear, then these are very highly useful, and less efforts are required. But just how you can implement these inbuilt functions from the NumPy or the other libraries which we are going to cover in the coming sessions. So now if you have any question, please, you can unmute your mic now.
Sir, sir, I
Yes.
write the question in chat box. Please say it.
Jitinder Kumar. Okay.
जी जी सर मैंने चैट बॉक्स पे लिखा है क्वेश्चंस प्लीज
Yeah. So, sir, can also unique, infinite, other type of the expression for,
सर
okay.
कैन बी फाइंड द यूनिक सॉल्यूशन इनफाइनाइट एंड नो सॉल्यूशन फ्रॉम द लीनियर इक्वेशन
Uh, yes, actually, the thing is when we these also depend upon the equations. Okay,
या
so if you have the unique solution in the equation, you can try. Yes, we can try. We can give example of this type of the problem, but the system or the way of to find out the solution will remain same. Okay, this will depend upon the value of determinant or the other operations.
या एंड सर आल्सो चेक द कंसिस्टेंसी रिगार्डिंग टू लीनियर सिस्टम
Pardon?
कंसिस्टेंसी फ्रॉम द लीनियर इक्वेशन
This also can be checked. Okay. Most of the
so
system, yes, please.
so which command be using for this operation
You can apply for all type of the problem.
so
Okay,
please
according to the
provide the
solution,
some practice questions so just we try it
हाँ जी.
एक प्रैक्टिस क्वेश्चन दे दीजिए नाउ वी ट्राई
Yes, yes, you can try.
या डेफिनेटली प्रोवाइड some question
Yeah. Yes, you can try. And if
थैंक
there
यू
is
सर
any
थैंक
difficulty or any doubt, okay, so feel free to ask. I will share the
या
entire file with you. You can choose your example according to your idea, okay, according to your problem. Apply all this by using this system of the way to solve the system of the equations, okay, and there will be no challenge. Yes. Any more question?
नो नो थैंक यू सर
Okay, thank you, dear participant. So the today's session is over now, and the file which I present just now, I am sharing with you. You must try all these questions, okay, and manipulate them, and how the values are changing, and how these operations are useful. Okay, you can take your own example, and also there are some examples which I did not cover. You can do all this. Just you are required some idea how we can use. Okay, so thank you very much to see this lesson, this session, and tomorrow we will resume the meeting at the same time. Okay, thank you very much and good night. You can access the file in your WhatsApp group.